Here is an excellent problem on maximum and minimum. We need to find the shortest line segment through a point. The question is, what is the length of the shortest line segment having one end on the x-axis and the other end on the y-axis and passing through the point 9 square root 3. So let's sketch this out here and then try to figure out how to do this question. So let's say this is our coordinate system and that's the shortest line segment we're talking about. And here let's consider that we have a point here which is 9 square root 3. So if this point is 9 square root 3, it really means that if I drop a perpendicular from here, it is 9 units from 0, and square root 3 is the vertical, correct? That is what it is. And let us assume that x and y intercepts are at x and y respectively. Then what we are supposed to find is the shortest length of this segment. Let this be r, correct? So this r is equals to x squared plus y squared, but then x and y are two different variables. We need to relate them somehow. So to relate them, what we can do is we can consider these two triangles. That means this small triangle and the big triangle, right? With the origin, they are 90 degrees each and that angle is common. So these two triangles are similar. Now since they are similar, their ratios of sides are proportional. So we can say y over x, which is y over x, this over this is equals to this height over this length. Now this height is square root 3, we know that. Now what is that small length? That small length is x minus 9, correct? So I can write this as x minus 9. But this ratio of similar triangles help us to relate y with x. So we can write now y equals to square root 3x over x minus 9. Now this relation will give it a number, and let's say this is our equation number 1. Now let's also find dy dx from here. So dy dx will be equals to, we'll use quotient rule. So quotient rule means denominator square, x minus 9 square. Numerator, so we have derivative of this, which is square root 3 times x minus 9, right? Minus derivative of this, which is 1 times square root 3x. So that becomes our numerator. Now we can simplify this at this stage and we can write this as equal to square root 3x and square root 3x cancel out. We get minus 9 times square root 3 in the numerator. Minus 9 times square root 3 divided by x minus 9 whole square. Well, so that is dy dx. Let me call this as equation 2. So we now have relation of y with x and dy dx also. That's great. Now what we will do is we'll relate r with x and y. So the length which we want to minimize, r, is actually equals to, or rather we can write r square is equals to x square plus y square, right? Now that's the relation. We can differentiate with respect to x both sides. So we get 2 times r dr dx equals to 2x plus 2 times y dy dx. So that is what we get after differentiation, and we can always cancel out 2 and simplify it a bit more. So we get this dr dx as equals to x plus y dy dx, correct? Now we'll take it to the right side and simplify further. Basically we need to find critical points. So now we'll find critical point. Now critical point is the one where dr dx should be equal to 0. So we want to put dr dx as equal to 0. That gives us the critical point. And that means x plus y over dy dx should be 0. Now y we know can be written as square root 3x over x minus 9, right? And dy dx can be written as minus 9 times square root 3 over x minus 9 whole square. So let's replace x, y with those values. So get plus y is square root 3 x over x minus 9, and dy dx is minus 9 square root, let me put it in bracket, otherwise it can create confusion, right, over x minus 9 whole square, right? So that is what dy dx is. So from equation 1 and 2 we got this. Now that can be simplified. Now dr dx is equals to 0, that means 2r, we can write even 2r, or rather r, because we cancel out 2, so there was r here, right? So when you equate dr dx equals 0, r times dr dx will also be 0. Okay, remember that part. So this has to be equated to 0. Let's try to simplify what we have here. So what we can write here as, we can take x minus 9 whole cube as denominator, right? So we'll take x minus 9 whole cube, that is this denominator, multiply by x. So we get x times x minus 9 whole cube here, and there we get minus, correct? So we get minus square root 3 times square root 3 is 3, and then 9 is 27, so minus 27x, correct? So that is what we get in the numerator. Now for that to be 0, the numerator should be 0, correct? Now that is, so we have basically dr dx equals to this particular function. Now we can equate numerator to 0 and solve. So x, we can take x times, let's take x common, right? So we get x minus 9 whole cube minus 27, which is 3 cube, equals to 0, right? Now this is 0, means either x is 0 or this factor is 0, correct? So let's first, x cannot be 0, because if x is 0 we have a vertical line. So that is not possible, but well, this could be 0. That means x minus 9 whole cube can be equal to 3 cube. In that case, this factor will be 0. That clearly gives us a solution as x minus 9 equals to 3, or x equals to 3 plus 9, 12. So we do get a solution of x equals to 12. Now at x equals to 12, what is the value of y? Y is square root 3x over x minus 9. Let's find that out. So y equals to square root 3x, we'll write square root 3, x is 12, over x minus 9, which is 12 minus 9, correct? So that gives us 12 minus 9 is 3, right? So 12 minus 9 is 3. So 3 divided by 12 is 4. So we get 4 square root 3. So that is the value of y. Now for this value of x and this value of y, we can always find the value of r, which is x squared plus y squared square root, right? So we have r, which is x squared, which is 12 squared. 12 squared is 144, plus y squared, which is 4 square root 3. 4 square root is 16, right? 16 times, and this is 3. Okay, that is what it is. So 16, well, 48 I could have written. So that is r. But before getting into this, we know we got probably the shortest length is this much. Let's first prove that this is indeed shortest, right? How do we do that? So for that, let's test the derivative itself, that is dr dx. So what we will do here is we'll test dr dx. We have one critical point, and the critical point is at x equals to 12, right? That is a critical point, x equals to 12. So let us take a test point on either side. So let's say the test point here is 11 and the test point here is 13. Close enough to 12. Now that's our derivative. Dr dx is this particular thing. Now, which we simplified like that, correct? Now here you can notice that if I write 11 for x, then 11 minus 9 is 2 cube, and this is 3 cube. So this gives me a negative value. So we get a negative value, that means it is decreasing, derivative is decreasing. But if I have 13 here, 13 minus 9 is going to be 4. more than 3, so this will be a positive quantity, so it will be increasing. And therefore we see we do have a minimum here, correct? So we have minimum at this point, correct? So we have minimum at x equals to, so we get minimum at x equals to 12, and we calculated y value as equals to 4 square root 3, and now we are calculating r, and r is equals to square root of, we have 144, and 16 times 3 is 48. So 48, we can add them up, right? So what is that? So 144 plus 48, so 8 plus, so let's do 144 plus 48, so 8 plus 4, 12, and 190, yeah, 192. So we get 192 here, correct? So 192 square root is our answer. So we can just use a calculator and figure out how much that is. So in a calculator, when you put 192 square root, what do you get? Square root of 192 is equal to 8 square root 3. That gives me 8 square root 3, or approximately, that's the exact value. You can change it and get 13.856. So we get 13.856. We can write 13.86 as approximate value. So that is the value of r which you get. Now this is a very, very important question. We will see this question a couple of times in different forms. So go through it once again. Remember one thing, that when you have this kind of a situation, you can relate the variables with the help of similar triangles. So that's the strategy used. Second thing, when you find the point, half the job is done. You have to really find the length of this particular segment. So this part is also kind of important. So go through all these calculations and then figure out what should be the length, right? So it is so many units. So that becomes our answer, right? I hope that helps. Thank you and all the best.